Hello dear learners, this is Xvii and I am going to teach you kinematics for standard 9. This is part 70. I am giving you deep concepts as per the engineering syllabus. So my lecture must be long. That's why it is a long series, isn't it? But the merit of these lectures are that you can have deep knowledge about the subject at your lower standard. And if you prepare earlier than others, then it is easier to crack engineering or medical exams when you will go to your to standard 11th and 12th. So now today I am discussing about more general case, or you can say how can you derive relationship between the physical quantities which I have previously discussed about it. So here I am giving you a situation that a body starts with a velocity u meter per second. Initial velocity is u, and he accelerates at the rate of a meter per second square for time t. Now let the final speed after time t is v meter per second. These are the symbolic representation. I can take the values also, but after taking values or numerical magnitude quantity, then we cannot have general relationship between these. So I am here taking only the symbols. So if I want to find the displacement of the body from A to B, how can you find displacement from A to B? So in part 1, here the given rate is a meter per second square. So what the rate signifies? It gives the idea that in 1 second, velocity changes by a meter per second, which I have already told you in the previous lecture. So in 1 second, speed or velocity changes by a meter per second. That's why if I say to you after 1 second, the velocity of the body would be u plus a. Have you got my point? Because the velocity increases by a meter second just in 1 second. Similarly, after 2 seconds, it must be u plus 2a. because after 1 second also it increases by a. So in 2 seconds the velocity increases by a plus a, 2a. That's why in 2 seconds velocity increases by 2a, and the final velocity after 2 seconds must be u plus 2a. Have you got my point? Now so the final velocity after t second you can get by unitary method. Can you get u plus a into t? Because I have told you that in 1 second velocity is increased by u in 1 and in 2 a, and in 2 second velocity increased by 2a, in 3 second velocity is increased by 3a, in t second velocity is increased by a into t. So the final velocity must be the addition of u. Have you got? So final velocity becomes v equal to u plus at. This is the practical interpretation of velocity or rate. Surprisingly, this expression I have already discussed in previous lecture by using the definition of acceleration, isn't it? But this expression can be found by the idea of the rate, how the speed changes per second. This is also called the first equation of motion. So you have to remember it to solve numerical problems in your chapter. This is called first equation of motion. I have already told you you can prove it by the definition of A also, because A is equal to V minus U by T. That's why you can manipulate this expression and you can get V is equal to U plus AT. Now, here my question is, can you apply the formula which you have already learned in your previous class, that distance is equal to speed into time? Can you apply it in this case when the velocity changes uniformly per second by a meter per second? My answer is no. Why I am saying this? I give you my valid reason that in the previous classes or lectures you have learned about that when speed is constant, then you can find out the total distance covered in particular time, and then you can apply the formula that distance equal to nothing but speed into time when the velocity or speed is uniform, means constant. Then you can apply it and you can prove it by unitary method also. But here in every 1 second velocity changes by a. So here velocity is not uniform, it is non-uniform. But acceleration is here uniform. Yes, acceleration is constant because rate is constant. Every 1 second velocity changes by a meter per second. But here velocity is not. So you cannot apply this formula. And I have already told you that in a straight line where direction is fixed. So distance is equal to displacement. So I can say displacement equal to velocity into time, but you cannot apply this formula in this case. So how can you find the magnitude of displacement here? Can you think about it by yourself? Just try it. Because if you have to learn about it, learn the physics and the science or anything, you must have to be creative. You must have to think about it, to write something, to calculate about it by yourself first. So now I have already discussed that initial speed is here u, and the final after t second velocity is v, and the rate is a times t. But I have discussed in the previous lecture that if you go in a straight line without changing direction, then the average velocity also gives the same answer as instantaneous velocity. Or average means what? Average means we have to represent all the data by a single mid-value data. Have you got my point? Doing average means we have to replace all the data by a single data which can represent all the data of that group. Have you got my point? But here the motion is in a straight line without changing its direction. So speed is same as velocity. That's why we can intuitively can say that average velocity can be treated as instantaneous velocity. And you know that the average means sum of data by number of data. So in the whole journey, average velocity must be what? Sum of data by number of data, u plus v, 2. This velocity represents the single velocity which body possesses at every point of time in the whole journey. Have you got my point? It may be actual, may not be, but it represents that the body keep this speed at every point of instant. Have you got my point? That's why we treat it as that the body moves in a straight line with the uniform speed of u plus v by 2. Have you got my point? This is a different angle you can treat this type of problem. Because for every problem there are many processes to get the same result. So by averaging, I have got a single velocity, and which symbolizes that at every point of instant it keeps this velocity. So we can say now this non-uniform motion becomes uniform motion by this velocity, because now velocity is constant. So automatically we can apply this formula, distance equal to velocity to time, because we replace all the velocity by a single velocity. Have you got my point? Now it is easier for you that this distance covered or displacement equal to speed into time. That's why I'm writing here distance covered by speed into time, and this gives the same result as I want to find out. Have you got my point? This equation can also be treated as equation. But if you simplify it, it gives the easier perspective of writing equations. So you have to remember it. In your case, for simple case, average velocity gives the same idea, same value in calculating displacement. So here is average velocity into time. Can you find it by your creativity, the displacement in this case, without using average? It may be complex, it may be some difficulty you may face, but just you have to try it. May you get the result or may not be, may not, but don't bother about it. Just try is enough. Now we can manipulate this equation in various ways. How can we manipulate this expression? We can replace v by the first equation of motion. I have already told you. After calculation, you must get this kind of expression. S is equal to ut plus half at square, or is nothing but ut plus at square by 2. Have you got my point? This is famously known as second equation of motion. Now you can try another pieces that if you replace t by this expression, I have already told you in the previous lecture, then you must find this expression, which is also called third equation of motion. You have to remember all these expressions because you have to use it. Have you got my point? So I give you overview of the equation of motion we have derived in this lecture. That there are three equations of motion we popularly known, that v is equal to u plus at, second is s equal to u2 plus half at square, and third is v square is equal to u square plus 2a. But there is another formula or expression also, s is equal to u plus b by 2 into t, and you can replace t by this formula u plus b into v minus u by 4 by 2a. Have you got my point? Now you can have another formula also, s equal to ut plus half at square, means u b minus u by a plus half a b minus u square. Whatever quantities are given in the problem, you can take the suitable expression from the formula. Have you got my point? You have to remember it also. Now I give you some harder pieces to you. How can you find out t from s? This is my difficult problem for today. So I have to find t from s, and we know that the expression of s in terms of t is s is equal to ut plus half at square. Yes or not? So we can arrange this expression as follows by transposition of s. Now if you know that what is the quadratic formula, it is minus b plus minus root under 2 b square minus 4ac by 2a. So I have replaced these formula by some suitable symbols here, and we get this expression. It may be harder because this is not in your class, but if you are interested, you can go through the 10th class chapter. It is not so hard as you think here. Now t has two values because in the formula there is plus and minus, so it has plus and minus two values. But time never be negative, so we can ignore it. So our real answer is this, minus u plus root under u square plus 2s. Have you got my point? Now this same expression can be easily derived from other method. You can easily understand it. If you don't want to use quadratic expression, then I have give you some another method. You can solve it. So replace t is equal to v minus u by a in the third equation of motion. Oh, sorry. Using t equal to v minus u by a and the third equation of motion, we can solve it. From third equation of motion, we can say that v is equal to root under u square plus 2s, because the square is gives root in the right hand side. By putting t, this value in t equal to v minus u by a. So we have got v, so here root under v square minus 2a by. This can be also arranged in this way. The same expression I have already solved by quadratic formula. So whatever easy for you, you can take it. Have you got my point? So I have given you the derivation or simple proofs of equation of motion. Mainly the three equation of motion, but there have many expressions also. You have to remember all. Now what is the meaning of nth second? This is our topic here. So what do you mean by first second? First second means the motion during 1 second from start. Have you got my point? And what do you mean by second? The motion during 2 second and 1 second. And the third second means motion during 3 second and 2 second. Similarly, we can say nth second means the motion during n second n minus 1. Have you got my point? So if I give you a problem that what is the displacement covered in first second? I have already told you first second means from a start to 1 second. So you have to find out the displacement from this to this. This gives the displacement in first second. And if you want to find the displacement between second means you have to calculate the displacement from a start to this and from this to this, and you have to take subtraction. Similarly, if I want to know the displacement between third second, then I have to calculate the displacement for 3 second and then displacement for 2 second, and we have to differentiate. We have to subtract it. Have you got my point? That's why I am taking here. You can easily understand that. And the second S2 minus S1, third S3 minus S, and nth Sn minus Sn minus 1. It means you have to subtract the displacement for n second and the displacement for n minus 1 second. I've already told you. After using the equation of motion ut plus half et square, you can solve un plus half n square for this Sn, and n minus 1 for n minus 1 t is n minus 1. So un minus 1 plus half a n minus 1. if you solve it, you can get the expression which is very important for you. Nth second, the displacement in during nth second is u plus half a 2n minus 1, or you can say it u plus 2n minus 1 into a by 2. If you encounter the problem in which it says that you have to find out the displacement in second, so replace the n by 2 and put the value of a and u, you can get the result easily. So I have discussed the various expressions of motion in this lecture. Now I am giving you some TAH problems. You have to solve it, and if you face any kind of trouble, you can mail me or contact Shiksha Vinaya for clearing the doubts. I'm here giving you TAH problem. Just write it and solve in your notebook. Now I am giving you another problem. Do yourself, and it is the only way to learn something. In the next lecture, I must give you the greater detail in motion. Thank you.